Okay, first video, polynomial operations. Make sure you have your notes out so you can take good notes. So let's just go over some definitions first. An expression that can have constants, variables, and exponents and can be combined using addition, subtraction, multiplication, and division is a polynomial. So polynomials cannot be divided by a variable. The variable's exponents have to be 0, 1, 2, 3, 4, keep going. So it's positive whole numbers plus 0. And it can't have an infinite number of terms, so it can't go on forever. And then standard form of a polynomial. You guys should know this, but let's just go through it. So here is a polynomial that is in standard form. This is a polynomial that is not in standard form. So if we look at these, the first one that is in standard form, it looks like our exponents go from greatest to least, right? And we end with a constant. The one that's not in standard form, the exponents do not go from greatest to least. So the biggest thing for standard form is that the exponents have to go from greatest to least, and then the last term should be a constant. Sometimes you might not have a last term because that constant might be 0, so you're just adding nothing. So that's the difference between standard form and not standard form. Everything, all your answers for all of this, they need to be in standard form, okay? A couple more definitions. So the parts of a polynomial that are being added or subtracted are the terms. The number in front of the variable is the coefficient. A term in an algebraic expression that cannot change because it contains no variable is a constant, so that's that last number. The term with the highest exponent is the leading term. The coefficient of the leading term is the leading coefficient, and the coefficient is the number in front of the variable. And the exponent of the leading term is the degree. So like, let's say you had your leading term was 4x to the 7th, the degree would be a 7th degree polynomial. Now let's name these polynomials. If it is a 0 degree polynomial, it is constant. If it is a first degree, it's linear. Second degree is quadratic. Third degree is cubic. Fourth is quartic. Fifth is quintic. And anything greater than that is the nth degree. So like I said before, if it was to the 7th, it'd be the 7th degree. If it was to the 20th, it'd be the 20th degree. Kind of makes sense. We also name polynomials based on the number of terms. So if there's one term, it's a monomial. That word's kind of hard to say, but it's a monomial. 2 terms is a binomial. 3 terms is a trinomial. Anything greater than 3 is a polynomial. And if you look at that, mono means 1, bi means 2, tri means 3, and poly means many. So it kind of makes sense. Now let's go over some examples. Let's look at this first one. The very first step when adding polynomials is to combine like terms. So in this first example, you always want to start with your highest exponent. The highest exponent in example A is m to the 4th. So I'm going to combine my m to the 4th. So I'm just going to put those in parentheses. 6m to the 4th plus 6m to the 4th. We don't have any m cubes, no m squareds, so we have to go to m. And we only have one. We only have 3m. So then we're going to add 3m. Then last we're going to go to our constants. So we have -1 and 6. We're going to add those two together. Last step is just to finish simplifying this. So 6 plus 6 is 12, so it's 12m to the 4th plus 3m, and then -1 plus 6 is 5. And you're done. Okay, let's do example C. So first we want to look for our highest exponent, which is 5. So we don't have any others. We're going to put -3n to the 5th by itself. Now let's go to the next one. We do have one that's to the 4th. So I'm going to put the -2 to the 4th by itself again. We don't have anything cubed. Let's go to our squares. So we have -6n squared and -5n squared. We're going to combine those two. Then the last one is just our n's. So 4n and 2n, we're going to combine those two. Then again, we just finish simplifying this out, and you end up with -3n to the 5th minus 2n to the 4th minus 11n squared, because -6 minus 5 is -11, and then plus 6n, because 4 plus 2 is 6. You're all done. Okay, these should be pretty straightforward. Really, all you're doing is combining like terms. So if you need to, you can do examples B and C. Here are the answers to those so you can make sure that you get the right answer. Okay? Let's go on to subtracting polynomials. So subtracting polynomials is very similar to adding polynomials, except we have to do one thing first. We need to distribute the subtraction sign so that we can change it to an addition. Okay, so let's look at example A. So to distribute that subtraction sign, we're basically going to change all the signs in the parentheses directly after it. So like in example A, how I drew these arrows, it's going to change all of those signs. So it becomes positive 5x to the 5th, minus 4x, minus 7x to the 4th, and then plus 7. Cool? And then you just combine like terms exactly like we did before. So the 5x to the 4th is by itself, or wait, what? That's supposed to be to the 5th. The 5x to the 5th is by itself. The 7x to the 4th is by itself. 6x cubed is by itself. And you have x minus 4x and plus 7. Again, that's supposed to be to the 5th, not to the 4th. And so you end up with, that's supposed to be to the 5th, 5x to the 5th minus 7x to the 4th plus 6x cubed minus 3x plus 7. You're all done. Okay, let's do example D. So we need to distribute that subtraction sign, but do you notice how there's a subtraction and an addition? So we just distribute the subtraction sign into the parentheses directly after, so just that middle parenthesis. And when we do that, you end up with negative x squared plus 7x cubed plus 5. Then you combine like terms, so the 7x cubed is by itself. The negative 4x squared minus x squared plus 2x squared, those are all together. And then the negative 8 plus 5 plus 1. You finish simplifying and you'll end up with 7x cubed minus 3x squared minus 2. You can double check my math if you want to, pretty sure it's right though. I have made mistakes before, like just a second ago. So I want you guys, if you need to do B and C, here are the answers to those two, so you can make sure that you get those right, okay? So now let's go on to multiplying polynomials. So you guys, this should mostly be review, so we're just going to go through this. There's two ways to multiply polynomials. You can do it with distribution, or you can use the box method. I'm going to show you distribution first. So if we look at this, distribution is when you distribute, I said that really weird, but you distribute whatever terms are in the first parentheses to the terms in the second parentheses. Okay, so we're going to distribute the x to the second trinomial and then the 2y to the second trinomial. Okay, then you multiply that out and you get 3x squared minus 4xy plus 5x plus 6xy minus 2y squared plus 10y. And then we're just going to combine like terms. And the only like terms we have here are the 4xy and the 6xy. And you might have noticed how I switched that negative 8y squared over to the front just because I wanted my squared terms first and then the terms with two variables and then my single terms at the end. Okay, and so then you just finish simplifying this. You get 3x squared minus 8y squared plus 2xy plus 5x plus 10y. And then you're done. There's an extra 6xy in your notes. This is wrong. They just forgot to move it over or change it or whatever. Okay, so this is the correct answer. Now let's go over the box method with this same polynomial. This one, there's two terms right there, correct? Then there's three terms in the second one. So I'm going to draw a 2 by 3 box. Then on the top of this box, I'm going to put the x and the 2y. Because that's the two terms right there. And then on the side, I'm going to put the 3x and the negative 4y and the 5. Okay? Then I'm just going to find the area of each box. The area is the length times the width, right? So this first one is x times 3x, which is 3x squared. The second one is 2y times 3x, which is 6xy. The third one is x times negative 4y, which is negative 4xy. The next one is 2y times negative 4y, which is negative 8y squared. Then x times 5 is 5x, and 2y times 5 is 10y. And then we just combine like terms exactly like we did before. Those are our only like terms. So we end up with 3x squared plus 6xy minus 4xy minus 8y squared plus 5x plus 10y. We combine those, we get 3x squared plus 2xy minus 8y squared plus 5x plus 10y. And I just want all my squared terms to be by each other, so I'm just going to switch the order of that. So it's 3x squared minus 8y squared plus 2xy plus 5x plus 10y, which is the same exact answer that we got before. So you can do it either way. I'm good with whatever. As long as you're getting the right answer, I'm happy. Okay? So let's just do a couple more examples. I know this is kind of long. I'm sorry. There's just a ton of stuff we have to go over. So let's do example B using the distribution method. So first I'm going to switch the order of these because it just makes it a little bit easier if we have the 2 terms on the one side and 3 terms on the other side. And then we're going to distribute those terms, so I multiply the 3x to the trinomial and then the 2 to the trinomial. When you multiply that out, you get 9x cubed plus 24x squared plus 15x plus 6x squared plus 16x plus 10. Then you combine like terms and you'll end up with 9x cubed plus 30x squared plus 31x plus 10. Okay? I went through that kind of fast, so if you need to pause it, go back and rewatch it. Let's do example C, but we're going to use the box method, and I need to make my screen a little bit bigger for this. So we have 3 terms by 3 terms, so I'm going to draw a 3 by 3 box. And it doesn't matter where I put which trinomial. I'm just going to put the first one on top and the second one on the side. And now I'm just going to find the area of each box. So 4x squared times 8x squared is 32x to the 4th. Negative 2x times 8x squared is negative 16x cubed. 6 times 8x squared, 48x squared. 4x squared times negative 3x, negative 12x cubed. Negative 2x times negative 3x is 6x squared. 6 times negative 3x is negative 18x. 4x squared times negative 7 is negative 28x squared. And then negative 2x times negative 7 is 14x. And 6 times negative 7 is negative 42. And now we just combine like terms. So we combine our x cubes, our x squareds, and our x's. We're going to end up with all of that right there. Then I'm just going to finish simplifying these, adding these together. And you'll end up with 32x to the 4th minus 28x cubed plus 26x squared minus 4x minus 42. And that's your final answer. You could do this one using distribution, except so you would have to multiply the 4x squared to the 8x, 3x, and the 8x squared minus 3x minus 7. Then you'd have to multiply the negative 2x to that and the 6 to that. So you're going to have a big long thing. Either way, you'll get that same answer. This is just a little bit more organized. That's why I prefer the box method. Okay? So you can do examples A and D if you need to. And those are your answers. Remember, hint on D, if you have something squared, that means you have it twice. So that's 2 minus 5x times 2 minus 5x. All right? Now, so we have this application. I want you to try to do this problem and try and figure it out. And then we are going to go over it tomorrow in class. So if you have it figured out, you're already ahead of the game. Okay? Cool. Make sure you take the quiz, and I will see you guys all tomorrow.